Alright, this is the walkthrough for test number 1, practice test. So in this video I'm going to be going through each of these problems step by step. You should see the work as I talk about it and be able to hear about it. So we're going to start with problem number 1. I've got b minus 16 equals 20. The objective when you're solving any equation is going to be to get the unknown by itself, or the variable by itself. So in order to do that, I'm going to add 16 on this side. The reason I do that is because adding 16 to a minus 16 would give me 0. So in essence it cancels out, and on this side of the equal sign I've got just b left. In order to keep it a balanced equation, I'm going to add 16 to the other side of the equal sign, so to the 20, and that's going to be 36. We can check our solution by plugging it back into the original equation, and you can do this for any of the equations that we're going to solve today. We're going to plug back in 36 as b, and we're going to write everything else the same. And if I plug back in 36, I will get 36 minus 16 equals 20, which is correct. So our check worked, and I can move on to the next problem. Problem number 2, 4 plus x equals 2. Again, I want to get x by itself, so what I'm going to do is to subtract the 4 because it's being added to the x. So we're going to undo that by subtracting it. We're going to do that on both sides of the equal sign. It's going to cancel out on the left side of the equal sign where the x is. On the right side, I'll have 2 minus 4, which is negative 2. And that's going to be my answer. Number 3, I've got z minus 1/4 equals 7/8. The way I can get z by itself is to add 1/4 to both sides. That gets rid of it on the left side of the equal sign. I'll have z equals 7/8 plus 1/4. In order to add fractions, we need common denominators. And I'm going to the lowest common denominator is going to be 8. So we can turn this 4 into an 8 if I multiply it by 2. Only allowed to do that if I also multiply the top by 2, so we're not really changing the value of that 1/4. We're just changing its appearance. So I have 7/8 plus 2/8, which is going to give me 9/8. So let me move this z down a little bit more. And I'll have z equals 7 plus 2 is 9/8. Number 4, I've got 35 equals 5 times x. You should be able to do some mental math and ask yourself 5 times what number equals 35 and come up with 7. But to show our work, I am going to divide both sides by 5 because that's what it's doing to the x, is multiplying. So to undo that, we're going to divide by 5. And on the left I have 35 divided by 5, which is 7. Alright, on problem number 5, I've got negative 30 equals n divided by 3. To get rid of the 3 on the right side, I'm going to multiply both sides of the equation by 3. 3 divided by 3 is 1, so in essence they cancel out on the right side of the equal sign, leaving just the n. On the left side, I've got to do 3 times negative 30, which would be negative 90, to keep the equation balanced. And that is my solution. Number 6, I've got 4x plus 2 equals 3x. I want to gather up the variables on one side of the equal sign. If you've got them on both sides, you want them on one side. And since the 3x has nothing else over there, I'm going to move the 4x to that side. So if I subtract away the 4x on the left side of the equal sign and do the same thing on the right side of the equal sign to keep my equation balanced, I'll be left with 2 equals 3 minus 4 would be negative 1x. I'm going to divide both sides by negative 1 to get x completely by itself. And I'll get negative 2 equals x, or x equals negative 2. Number 7, we've got variables on both sides of the equal sign. So the first thing I would want to do is to gather them up on one side. So I'm going to add 5r to both sides. Negative 3 and positive 5 would make 2r, positive 2r. And I can add 8 to both sides at this point. Cancel those 8's out, and I'll have 2 times r equals negative 4. Let's divide both sides by 2, and kind of running out of room, but I get r equals negative 2. For number 8, we've done a couple of these in the bell work recently. You've got to deal with that 3 before you can do anything with the minus 4. So I'm going to multiply the top by 3, and I'll multiply the other side by 3 as well to keep it balanced. Cancel out those 3's. I have x minus 4 equals negative 3. Add 4 to both sides, and we get x equals 1. For number 9, before I can set up case 1 and case 2 that we'll need to do for absolute value, I'm going to move everything else to the other side of the equal sign. So we'll start by subtracting 4 from both sides. And we'll have 3 times the absolute value of y equals 31 minus 4, or 27. Then we need to divide both sides by 3. And I'll have the absolute value of y is equal to 9. And I'm sort of running out of room here. I'll have case 1 y is equal to positive 9. And case 2, y is equal to negative 9. The reason we do that is because the absolute value of positive 9 equals 9, and the absolute value of negative 9 equals 9. So we have to consider both cases for absolute value equations. Alright, because of room, I'm going to pause the video, probably add another clip to do the other ones on a bigger area.